Okay, today we're going to talk about a few things, a couple of different things. One is difference of squares and also perfect square trinomials, and we're also going to do an introduction to factoring today. We'll probably need to split this into two videos to make it fit. But let's go and start with difference of squares. And this is something we're going to hit more a little bit later in the week. But basically, if I have something like x plus 7 times x minus 7. If I multiply this out using the distributive property, I end up with x times x, which is x squared, x times negative 7, which is negative 7x, 7 times x, which is plus 7x, and then 7 times negative 7, which is negative 49. Combine our like terms here in the middle, and we end up with x squared. Oh, those zero out. So we end up with x squared minus 49. Now, the reason this is called difference of perfect squares or difference of squares is because x squared is a perfect square. That's x times x. 49 is a perfect square. That's 7 times 7. But the word difference also means subtraction. So we end up having the difference of two perfect squares, and if you look up here, these are almost identical except one's a plus and one is a minus. And a little bit later in the week when we talk about this again, that's going to be something that we really emphasize. The next thing I want to talk about is something called a perfect square trinomial. And so for this example, let's just do x plus 9 quantity squared. Now, what a lot of students want to do here is they want to just square the x and square the 9 and get x squared plus 81, but that doesn't work. They want to use that property of exponents, but this plus sign here changes everything. That only works for monomials. If you look back, there was no plus or minus signs when we were doing any of those. So what this square right here actually means is it means x plus 9 times x plus 9. So now when we multiply this out, we get, x times x, which is x squared, x times 9, which is plus 9x, 9 times x, which is plus 9x, and 9 times 9, which is plus 81. Combine our like terms here in the middle, and we end up with x squared plus 18x plus 81. Now this is called a perfect square trinomial. It's a trinomial because there's three terms, but also because it came from a perfect square. X plus 9 squared simplified becomes this. We'll talk more about that when we do the factoring aspect of this. Okay, so let's go ahead and let's jump into today's more specific lesson. And this is going to be an introduction to factoring. So, introduction to factoring. Now, an intro to factoring. Factoring is about breaking expressions into small pieces that are multiplied together. Small pieces that are multiplied together. There we go, it just made it fit. So, let's talk about GCFs first, the GCF. GCF stands for greatest common factor. And we're always whenever we factor, we're always going to be looking for GCFs first. You're gonna hear me talk a lot about that within the next week or so, when we're hitting lots of different types of factoring. But let's go ahead and do this first. So for example 1, let's do 27y squared plus 18y. And So when we find the greatest common factor, we're looking at it with the regular numbers, the coefficients, but then we're also looking at it with the variables. So first we're going to find the GCF of our regular numbers, which is 27 and 18. And when we do this, the greatest common factor, 3 goes into both of them, but 3 isn't the biggest. The biggest number that goes into both of them is 9. So the greatest common factor coefficient, the number part, is the regular number part is 9. Now let's look at the variables. They both have y's. So we want to find the GCF of y squared and y. Now the idea here is if each term has that particular variable, you're going to just take the smallest exponent that's on that variable. So here we have a 2. This is understood to be 1. So the smallest exponent's 1, so it's just going to be y. So our GCF equals 9y. Okay, so now when we multiply this out, when we write it out, I mean, we're going to divide out the GCF and put it in front of the parentheses. So we have our 27y squared plus 18y. We're going to divide 9y out of each term. Then when we write our answer, the 9y is going to go in the front. So now when we reduce this, 9 goes into 20, whoops, here we go. 9 goes into 27 3 times. Y squared divided by y. Remember, when you're dividing like bases, you subtract the exponents. 2 minus 1 is 1, so it's just going to be y. And then plus, whoops, that should be an 18. Then 9 goes into 18 twice. Y over 1 divides out, so that's just becomes that's just the 2 that was in the beginning. So this is going to be our factored answer. Now, one really cool part about this is you can check your answers. So let's do that. Let's check our answers. And that is, so if we have our 9y and then 3y plus 2, if we multiply that out, we're going to 9y times 3y is, 27y squared. Y times y is y squared plus 9y times 2 is 18y. Is that what we started with? It is. So this is going to be our factored version. Okay, let's hope I have time to do this next example before we do our other practice problems. So this next part is going to be to factor ax squared plus bx plus c. And this, we're going to do this when a equals 1. Now, a is always the number in front of x squared. B is always the number in front of x, or whatever the variable is, the squared variable, the plane, the single variable, and then c is always going to be our constant. And so for this one, I want to, this will be example 2. I want to factor x squared plus 7x plus 12. So this time we're factoring a trinomial. It has 3 terms. One thing that I want you to remember, and this is big, when a equals 1, tomorrow we'll do a different method, but a, in other words, there's not a number in front of x squared other than 1. When a equals 1, you want to ask yourself, what numbers add to get b being the number in front of x right up here, single variable, and multiply to get c. Okay, I'm going to go ahead and stop this video here, and we're going to go on to, go to the next video.